I entitled my talk today Trillions, and you'll see why in a minute, but I'm grateful for this opportunity to be here, to receive this award. I've told several of you that I think they must have lowered the bar this year, because if you look on the back, there's people like Nolan Bushnell, who is quite famous in our industry, and some others who are just outstanding graduates, and so I'm honored to be listed in the same list as them on the back of the program. We live in a world of complexity, and if you think about it, there's a lot of things that are much more complex than they used to be. Let me just give you a couple of examples. One that's not technology related. I don't know how many of you know, but there was a thing called the tortilla riots in January of 2007 in Mexico. And if you look and say, why was there a tortilla riots? It's because the price of corn went up 400% in 3 months. And hit a price of 35 cents per pound, which was higher than it had ever been, and people couldn't afford to eat. So there were riots protesting mainly the politicians and the farmers, and they were a little misdirected. But the actual causes of that were very complex. It turns out that it started with subsidies for the corn industry in the United States. And then we put NAFTA into place. And so because of NAFTA, then these multinational companies like Cargill and Archer Daniels Midland were able to go and corner more of the market, so to speak. In fact, they were able to sell corn at a price that put Mexican farmers out of business. And then we had a thing called Katrina that hit. And Katrina took out the oil drilling platforms and caused people to think about our energy resources in the United States. And even the US Congress got involved and said, well, you know what, we probably need to convert more corn to fuel. So they started paying farmers to plant less corn and more of the kind you eat, and more of the kind that you turn into ethanol. And ultimately what happened is that the price of ethanol and the price of oil became linked. So after the Hurricane Katrina, as the price of oil escalated, so did the price of corn, and resulting in tortilla riots in Mexico. So there's these things, and often we call these black swan events. There's these very complicated situations that arise. Well, it turns out that doesn't just happen in those kinds of areas, but it happens in technology areas as well. So the reason I picked this topic is I've been dealing with the complexity of information technology in my current job. And this is, I know you can't read this chart, but this is just kind of the levels of the architecture that exist in a university. And we had some interesting problems. So this just kind of points out all the different levels, all the different kinds of systems that have to all work together in order for the IT environment to work. Well, we had a meltdown down at that university that can't be mentioned down in Provo on Memorial Day last year. And what happened was we had moved for several years to virtual servers. And I know some of you won't know what that means, but I saw a VMware shirt today, so there's somebody in the audience who understands that. They moved to virtual servers. And then they said, well, if virtual servers are such a good deal, we ought to move to virtual storage. So they put in a system called Falcon Store that had some very high-speed memory, disk memory, and actually it was flash memory, and then slower disks behind it. And on Memorial Day, as they were doing upgrades, it overloaded the storage system. And it turns out that computers are used to the idea that I can't get to the network, but they're not very used to the idea that I can't get to my disk. And so what ended up happening is it corrupted the tables in the virtual storage system and took out half of that university's IT systems overnight. And it took them months and months to recover. So my job for the last while has been to look at the complexity of IT and see what we can do to make it more resilient. And so I always have this hope that things will get simpler as we go on. Einstein said everything should only be as complex as it needs to be, and no more complex. Everything should be as simple as possible. And no simpler, I guess is the way he actually put it. And so I thought, well, someday maybe we'll get to where these systems actually get easier to maintain. But it dawned on me as I was doing research and reading that, in fact, we're not headed that way at all. So I entitled this talk Trillions. So just to give a little calibration, what does trillions mean? I got this slide here. 1 million seconds is just about 12 days. So your heart beats 1 million times every 12 days or so. 1 billion seconds is 31 years and 8 months. So those of you who are over 32, congratulations, your heart has pounded 1 billion times. And if you go to a trillion, though, a trillion we think of just the next number, right? Million, billion, trillion. Well, it turns out that a trillion is really a lot bigger than a billion. You have to go back 32,000 years, basically, to go back a trillion seconds. And in money, you know, we can talk about the Obama budget, but probably going to leave that alone. But in money, that bottom square is $1 trillion compared to the, you know, 100 million or billions, which is quite a bit smaller. So the internet today has 2 billion users, give or take. And there's more computers on the internet than there are people in the world. And more microprocessors built every year than there are people living on the planet. So we've reached the point where there's billions, many billions, not trillions, but many billions of devices that are being connected in the world today. And almost everything we have that's got electricity going to it has a microprocessor in it. So things like vacuum cleaners, washing machines, microwaves, wristwatches, they all have computers in them. And I remember when I actually was growing up, about the age of these graduates, I worked summers at Hughes Aircraft Company where my father worked, and he had a story to tell about how the world had moved from analog to digital. Well, we moved from digital computers, PCs. I think the PC era is coming to an end, and we're going to move to an era with trillions and trillions of devices that will all be communicating, interconnected. But, you know, if you look at washing machines, why do they have computers in them? It turns out that those old mechanical timers were expensive, at least relatively speaking. And so it's cheaper to put a microprocessor in. Now you got to pay the complexity somewhere, and you pay it by writing software. But you only have to write the software once, and then every time you ship a washing machine, you get the benefit of the fact that you don't have to put that expensive timer in. And so more and more things are getting computers embedded in them. And we can see that everybody carries computers around these days, right? I mean, this is a computer. I have 3 of them with me today. We just re-architected how we do wireless networking on campus, and we decided that for new buildings, or when we do new renovations of buildings, we're going to make so there's 2 megabits per second to every person in a classroom. So every student will be able to have essentially video coming to one of their devices, and they plan for everybody to have up to 3 devices. I think that's a little short-sighted, frankly. I think that some people now have 7, 8, 9 devices. I don't know if any of you have a Fitbit. Right? That's another device that monitors how many steps you take a day, and it talks to the computer. People are starting to wear monitors, and you know, if you read some science fiction literature, you know, maybe even get to the point where you have wearable computers. That's not, and even Google today, right? Google Glasses now, you can have Google Glasses. So we're going to have more and more things that connect to the internet. And connectivity is becoming cheaper and cheaper. So I saw several projects today in these presentations that were using Arduinos, which is about a $5 computer. And if you combine that with some Wi-Fi device, probably still for under $20, you could have a computer that you could put on anything that would talk wirelessly to the internet. So it's getting cheaper and cheaper. But there's this thing called Moore's Law. And every year, basically what Gordon Moore said is that every 18 months the complexity of computers doubles and the price, you know, follows a similar trend because things get cheaper and cheaper. So the microprocessor today that you guys are using, the $30 to do Wi-Fi and a Raspberry Pi or a Arduino, you know, in your lifetime will be 3 cents. And when a computer is 3 cents instead of $30, you're going to start putting them in everything. And everything is going to have a presence on the network somewhere. And so we're going to get this huge network of things, this Internet of Things that are going to create. Now everything won't be directly connected to the Internet, but everything will have, you know, a computer basically embedded in it. Because why? Why would you embed computers in everything? Well, if you look at the world today, and you say, I can go buy a bathroom scale, you can buy one for about $40. But if you want to buy one that connects to the Internet, it costs $120, a living scale. And so every morning when you step on the scale, it will automatically record your weight to someplace out in the Internet and out in the cloud. And apparently that's worth something to people. They'll pay $80 extra to have their weight transmitted every day out to somewhere where probably somebody's hacking it and they can find out what your weight is. So in the future, maybe even things like chairs and tables, when they manufacture them, they'll have an embedded computer like we think people do today with RFID chips, but there'll be even more of that going on. Can you imagine a world where you sit down in a chair in a movie theater and it knows how you like your seat adjusted? It will adjust to you because it senses that you're there and you're sitting in that chair, and it would adjust to you. Today we walk into offices and we think nothing of picking up somebody else's pen or pencil, whatever's laying there, we just use it. Well, I think computers will become that way. We'll walk in, pick up somebody else's computer, and we'll use it. Our data won't be in the computer. Our data will be all around us. And that'll be a device that we can use for a period of time. While we're holding it, it's ours. When we put it down, it can belong to somebody else. And you know, when computation gets that cheap, that's the kind of thing we're going to see happen. You know, today there was one presentation, Brad Magers, that was interesting because he put sensors all around the room so he can detect when people fall down. And that's an interesting idea, but those kinds of sensors could be used for those things and a lot of other things. We'll have rooms with sensors, we'll have more sensors going on than we can imagine today, and they'll all be connected. If you think about your automobiles today, it doesn't matter whether you drive a Honda or you drive a Mercedes, your car has about 30 computers in it. Every door, if you've got power windows, you've got power locks, you have a computer in the door. Why? Because it's cheaper to run one wire to talk to the computer than it is to run all the power and things for the motors and everything else separately. So, you know, and we haven't got to that point where our homes have 30 computers embedded in them, but why not? Why aren't there computers on the doors that are monitoring the doors, that lock the doors, that control the lights? You can do some of that today, but I think we'll see that happening more and more. I think everybody and everything will have a presence on the internet. Some of those connections will be permanent. Like hopefully my connection with my wife Barbara is permanent and that won't change all the time. My connection with a chair in the movie theater will change all the time, and we're going to need new technology for how to deal with all those kinds of things. There's a quote by a man named William Gibson that I think I have here. The future is here, it's just unevenly distributed. So some of you in this room already know what the future is going to look like. Other people out in the world, you know, don't have a clue yet, but it'll get there eventually. So the way things work today, though, won't be the way they work in the future. So let me give you some examples of that. Today, if I go and buy one of those scales I talked about, I get the hardware from Costco or whatever. Then I go out and I have to have an account at a website, and then I have to have a mobile app, right? So and then I can do that, but the scale doesn't talk to anything else. And what happens when instead of 100 or 10 or 100 things, I have thousands of things that I own? Do I have to get a different app for every single one of those? Do I have to have a different account somewhere on the internet? So the architecture that we're using today is going to have to evolve and change. But we will all have thousands of things that we own that have a presence on the network. We're heading basically very quickly towards a complexity cliff, and it's going to take a lot of work to figure out how to address those issues. There's some interesting things that have happened. I read a story about a guy who bought a brand new flat panel TV, and it worked great for the first couple of days, and then suddenly the whole picture hung up and it froze. Tried turning it off, it wouldn't respond to any buttons. Finally had to pull the power plug and stick it back in, and then the TV worked just fine. The software in it had gotten in a funky state, and the TV wouldn't work. Well, can you imagine what would happen if instead of the TV hanging up, you had to reboot the ambulance and it took 10 minutes for your ambulance to get going again? I mean, we just can't have that kind of problem. So while the complexity is inevitable, the dysfunctional complexity is not. We need to focus on creating systems that have beautiful complexity, things that work well. We will get to a place where there will be connections everywhere as well. And we'll have to have different kinds of interfaces. Now, when some of you probably remember this, when the Wii came out, the video game, all the gamers hated it. But the general population could finally get back into the video games again because the interface was easier and intuitive for people to use. And that's what we're going to have to do, I think, with computers as well, just make easier systems to use. There will be connections everywhere. You'll have connections to things you own. You'll have connections to things you don't own. And there will have to be different kinds of connections for different kinds of devices. For example, if I had an electric car, and that would be kind of fun to have an electric car, I don't have one, and then I had an air conditioning system in my house, You know, there are places in the country now where you get lower rates if you use power at certain times of day rather than others. So you'd like your car and your air conditioning system to negotiate with each other and the power company to determine whether, you know, what's the best time to charge your car. And when should you be running your air conditioner? And that way you could save a little money. But today, if you wanted that to happen, you'd have to buy them all from the same vendor. You'd have to go to Apple, because they're the only people who can pull it off. You'd have to have an Apple car, an Apple air conditioner, and, you know, basically the other ones. And your power company would have to be Apple. And if you did that, then everything would work. But today, systems don't interoperate the way that they need to for that. We need a much more decentralized and distributed system than we have today. We like, as humans, we like central control. You know, if I controlled all the traffic in the world, my neighbor would never back his car into mine, right? I mean, we like to have this command and control environment, but the reality is that we're going to enter an era of more distributed and more decentralized systems. And that can be good. We have an example of that. It's called the internet. And I'm sure many of you know this, but the internet was originally called the ARPANET, and the University of Utah played a critical role in creating the ARPANET. They were one of a handful of universities that created the technology that became the internet. And so that's an example there. People add computers, they take them off, and it's pretty resilient, and it's a distributed, totally distributed system. There's another one that you all are involved with every day. If you go out on Utah's highways, it turns out that's a very distributed environment. We have not autonomous vehicles, but we have autonomous drivers, and we have a set of protocols. To come to a red light, you're supposed to stop, and if you go to a green light, you can go. And we have rules for merging, and if you follow these protocols, everything works pretty well, and usually you can survive the day. But that is a very, you know, distributed, decentralized system as well. When originally I started playing with computers, the data was on a set of cards, right? That's punch cards, which most of you have never seen. Then the data migrated into the computer, which you all know, you have your data in your PC. And now data is migrating out of the computer into the cloud. And you can see that with email. Most of you now have your email out in the cloud. Gmail or Yahoo or whatever you use is no longer on your computer. And that needs to continue. We need to have a way where all these devices can find the data they need to, because it can't be stored on one computer. And so we need a global information space to support that, which we don't have yet today. But we do know some things about what that has to look like. Every node in the network will have to have its own unique identity. That's not too hard to do. People know how to do that. It'll have to be persistent. I think one thing funny about persistence is that, well, I guess it has to exist during the life of the device. But today, if you read papers, the academic papers that people write, they have a lot of links to the internet and to sites on the internet. You know what? Those things disappear all the time. There's academic papers that you can now no longer go and look at what their references were, because the sites they referenced are gone. There are people who have lost their data, their pictures or whatever, because some company shuts down and no longer has their data available. So we're going to need a place where we can put stuff that won't go away. So I have to be persistent. Everything will be programmable. Devices will interact not just with people, but with each other. And there needs to be some sort of consistent behavior. Today we put up with learning Mac OS or Ubuntu if you're a Linux person, or Windows, which most of us use, and you learn a different interface on your iPhone. But we're going to have to get more consistent behavior. So what's that going to mean to all of you? How will it change your life? Well, there'll be good things, I think, and bad things about it. My in-laws are interested because they don't own a computer. I go to their house to stay there, and I can't even get on the internet, and I go into withdrawals after about 3 days. But this will change. It'll change some people's lives more than others. We don't know whether we're facing a utopia or a dystopia. But and I think that, like most things, it won't be one extreme or the other. We'll find some place in the middle with this new information age of trillions of devices will be. I think what's important for all of you to think about, besides the fact that there's trillions of devices coming, is that market forces, especially students, market forces could choose between a Palm and a BlackBerry, and they did. Palm lost, BlackBerry won for a time, but market forces did not decide to create an iPhone. And the iPhone is what really changed phones. That took human ingenuity. That takes the kind of activities that engineers are involved in. That's the creative spark that all of you are being trained to do, to go out and create new things. Having worked at Intel for a decade, I met most of the founders of Intel, but one of them, Bob Noyce, had passed away before I joined Intel. He actually died quite young. But every time they only named one building. Intel Corporation has hundreds of buildings. They only named one. They named it after Bob Noyce. And whenever they do training of new employees, they always do one quote by Robert Noyce that I'd like to share with you. So I encourage all of you students to not be encumbered by history and to go off and do something wonderful, because it's you who are going to make the difference to whether this trillion-node network that we're going to be facing, these trillions of devices in the world, are going to be a utopia or a dystopia. And so I encourage you all to go off and make a positive contribution and lead us out in a way that will be a great place in the world to live. So thank you for your time.